Okay guys, and yesterday up to here we making relationship. Okay, so after creating relationship, then later what it was happening, let me see guys here. So yesterday the two tables we designed for making relationship. One is department number one and one more is EMP1. Okay now? So this is what yesterday we making relationship in between table. But after creating relationship in between tables, okay, there are two rules are coming to picture guys. Okay, so no point. So what we said here, once we created a relationship tables, there are two rules. There are two rules coming to picture. Okay, come into picture. So what are those two rules here? Observe here. Okay, so first rule is called as guys here insertion rule. First one is called as insertion rule, and second one is called as here deletion rule. Deletion rule. So these are the two rules are coming to picture. So what is the rule here? Insertion rule and deletion rule. Then what it was telling, insertion and deletion rule, observe guys. Okay, so insertion rule is telling us, okay, we cannot insert values into foreign key column cannot insert values into foreign key column. Those values are not existing. Those values are not exist. Those values are not exist or existing in primary key column of a parent table. So this insertion rule is telling we cannot insert values okay. Now we can observe. So insert into EMP1 okay, now we can see. So insert into EMP1 sending values 106 and some name is, for example, Miller, and if I inserted 30, so this is not allowed. So this rule is satisfied. That means integrity constraint is violated, and whatever the 30 we are inserting into foreign key column, the 30 is not okay existing in parent table. Okay, so this is the error whatever we got it, and the same thing your insertion rule is telling us. The same thing your insertion rule is telling us. What it was telling insertion rule, we cannot insert values into foreign key column. Those values are not existing in primary key column of parent table. Okay now, so this is it was happening. Okay now, right? And the second rule is what it is here, deletion rule. So deletion rule, what it was telling guys here, deletion rule what it was telling, we cannot delete, we cannot delete a record or a row data from parent table, and those records and those rows are associated, those rows are associated, those records are, those rows are associated with the child table, with the child table without addressing, okay, without addressing. Okay, so second rule is what it was telling, we cannot delete a row data or a row from the parent table. Those rows are associated with the child table without addressing. Okay, so second rule is what it was telling. Suppose user try to deleting a record from the parent table, that record is associated with the child table. Okay, then we cannot delete here. Okay, so it means what now, let me come back. For example, I'm going to delete from parent table. What is my parent table here? DEPT1. Delete from DEPT1 where department number is equals to 20. So in the department table, okay, in the department 1 table, 20th parent data I'm trying to deleting here. Okay now, but what it was happened guys here, this 20th row data is associated with the child tables. The 20th row data is associated with the child tables, yes or no? So it was associated here. So whenever, that means 20th parent is having children's, associated with child table means having children's. So when you want to try to delete it here, then what it was happened, it was not allowed, and it was showing the clear error, integrity constraint is violated, and here it was telling child record is found. Here it was telling child record is found. Okay, child record is found. So why it is child record is found means, the reason is what now, see which parent data are you deleted, that parent is found, the parent is having what now, children's. So that's why without addressing to child, you cannot delete a parent. Okay, so whenever you try to delete a parent, but the parent is associated with children's in child table, then we cannot delete without addressing. So without addressing, we cannot delete. So this is second rule is telling us. This is second rule is telling us. Okay, now in this rules, okay, the first rule is what it was telling, we cannot insert value into foreign key column. Those values are not existing in primary key column of parent table. So that means, simply if you want to understand what it was saying here, no parent, then then no child. This is first rule, guys. So what it was telling, no parent, no child. This is first rule meaning. Second rule is what it was telling. Okay, we cannot delete parent row, okay, without addressing to child. This is second rule is telling. Now this, whatever the shortcuts I was given here, by seeing of this shortcut, can you tell me, guys, can you guess here, if we have a chance to break a rule, then which rule is possible to break? First rule or second rule? Can you guess? Can you guess, guys, which rule we can break it? First rule or second rule? Come on, guess, guys, all of you. Yes, we have a the chance we can break a second rule, we can break it, because first rule we can't break it. Why we can't break it? First rule means this is the fixed rule, that is a universal truth. Okay, when there is a no parent, then there is no children. That is a universal truth. So that's why that rule we cannot be break it. That's why that rule we cannot be break it. But here one logic is observed. No parent, no child. This is a perfect, and we can't change anything in this case. When parent is not there, there is impossible to have a children. So this rule we cannot touch, and we cannot change also. Okay. But second rule, what it was telling here, we cannot delete parent row without addressing to child is telling. Okay, so without addressing to child, we cannot delete. Okay, fine. It means indirectly we can observe. What it mean indirectly? Suppose we can delete parent row, okay, with addressing to child. So point is clear now. So without addressing to children, parent cannot be deleted. So here, without saying that, suppose you just assume without addressing to children we can't. It means that with addressing to children we can. Yes or no? So that is what it was telling. So then how we can go to addressing to child? Okay, how we can go to okay, break this deletion rule, and how we can addressing to child. Okay, there is, yeah, here one point is there. If we want to delete parent row. Okay, delete parent row. From parent table, then we use some rules. Then we use some rules are rules are those rules are are called as which rule here? Cascade rules I want to use. Okay, if you want to delete parent row from parent table, then we use some rules, and those rules are called as a cascade rules. And these cascade rules are two words, guys. One is we called as a on delete cascade, and second one is called as a on delete set null. Okay, on delete cascade, and second one is on delete set null. So these are the two cascade rules are there to overcome, otherwise to break your second rule. To break your second rule. Okay now. So what are those? On delete cascade, on delete set null. So what is on delete cascade and what is on delete set null? What it was telling, these rules are observed. Okay. On delete cascade, when I use here, what happened here? When we delete row from parent table, then the associated rows in child table also deleted. Okay, now the point is observed now. So whenever you want to delete, okay, when we delete row from parent table, then associated rows in child table also deleted. This is the on delete cascade is telling us. Okay, let you see how it was using. Come back. Now I'm creating table, guys. Here observe, create a table. The table name DEPT2, and I'm passing department number, integer, primary key, department name, varchar 2 of some size. Okay, that was over. Later, as usual, I'm going to sending some information, DEPT2, sending values, department number 10, department name is bracket. The same to same, DEPT values 20, the department name is Java. So same as this. So I just made it commit, and the first parent table is successfully created. Department to parent created. So now children observe, careful observe children. So create a table emp2 of EID integer. Okay. Next, what was there? Ename. So varchar 2 of some size. Common column department number integer. So what you applied here? References. So are you taking references from which table? Parent table. So this time a parent table is DEPT2 of DEPT number. So along with this, now I need to add what I need to add here? On delete cascade. So which rule I'm applying here? On delete cascade. So this rule is I applied. Okay now. So create table emp2, ID name as usual, department number is a common, enter references from parent table of DEPT number column, and what I was applied here additionally, on delete cascade rule is applied. On delete cascade rule is applied. Okay, so now once you have to execute now, table is created. After created, let you see to insert your data, emp2 values, ID 1021, name is Sai, some reference is 10, so 10 is accepted. Okay, next 1022, the name is Jones, one more employee accepted. 1023, the name is Adams, 20 is accepted. 1024, the name is what, 20 accepted. So I just commit here. Finally, can you see, select star from, okay, DEPT2 parent table, EMP2 child table. So now first rule is insertion rule. Suppose are you inserting, insert into EMP2 sending values 1025 and some name I'm giving here Alan, and if I'm passing 30, so this is not allowed, we know, because 30 is not there in the parent table primary key column. So that's why child is not allowed. So this is a fixed rule. This rule cannot be changed. So it was telling what, now simply no parent, no child. So this is okay. But second rule is observed. What is deletion? Delete from DEPT2 where DEPT number is equals to 20. But previously the same thing I did, but it is what it was showing error and telling that it is not deleted. But now after applying your on delete cascade rule, then you can check it here. Then you can check it what it was happened. So one row is successfully deleted. So one row is successfully deleted. Now you can go and call your parent table. So parent table data deleted. So parent table data deleted. Come on guys, deleted or not? Okay, right. So parent is deleted. But after parent, let you see guys your child table, EMP2. Then what happened guys here? Once you deleted parent data, automatically the associated child records also deleted. Yes or no? Once you delete parent, automatically child is also deleted. Yes or no? Okay. Yes. So that means this rule all of you understand now. So on delete cascade rule now understand. Come on guys. Yes. So this is on delete cascade rule, the purpose. Second one is what now? On delete set null. On delete set null. So this will be happen what it was when we delete row from parent table, then the associated rows in child table are converting into nulls converting into nulls. So that means, guys, here in this case what it was happen, your child record is not deleted, parent data deleted, but our associated children's are not deleted. But data children's records are not deleted, children's rows are not deleted, but what it was happen, those data is converting into nulls. That is called a on delete set null. Okay, in the name only there, setting null. Okay, let you see, guys, here. So now this is, you can go to check out here, same as usual. Let you come back. So I'm creating again table. Let you see department number 3, and as usual department number, integer, primary key, department name, I will take it here. Okay, right. So now created, fine. Now insert into, so DPT number 3, sending values of n comma Oracle. Next 20 Java. Okay. So now it was happened, guys. I inserted 2 records in this parent table. Okay, fine. The parent table successfully we designed here, DPT3. In the same pattern, child table. So child table, EMP3 offer. So everything up to here, I will take everything same. But okay, department number 3 offer, DPT number, reference column. Then what we need to apply here means on delete set null. On delete set null. Okay, let you see. So after table is created, let you see insert into EMP3 sending values. So 1021, the name is Sai, and 10 it is allowed here. Like in the same to same. So 1022, the name is Ellen, 10 it is also accepted. 1023, the name is Word, and 20 this is also allowed. 1024, okay, the name is Jones, and 20 it is also allowed. So I just made it commit, and finally select a star from DUPT3 parent table, select a star from EMP3 child table. So these are Again, we design here the tables, but this time I'm using one more cascade rule that is called as what now? On, delete, set, null. After that, as usual, your two rules you have to check here. Insertion rule. First, I have to check insert into DEPT number. Okay, sorry, EMP na. So EMP3 sending values 1025. The name is Scott, and if I'm giving 30, so as usual, it is not allowed because parent key is not found. Okay. Now you can come to deletion. Now you can come to deletion here. So delete from department number 3, where what you say, the department number is equals to 10. Now 10th record I'm going to take in here. Okay, 10th record I'm going to take in here. Okay, now you can see. So now what it was happened when I deleted the parent row, yes, successfully deleted. Now we can come back and see DEPT3. So 10th record is successfully deleted. And what about children? You can see the EMP3, the children you can see. So now you can see 1021 Sai, 1021 Ellen. So children's records are not deleted. Children's records are not deleted, but that 10 number is converting into null. The 10 number is converting into null. My point is clear, all of you now? Come on, guys, all of you clear this on delete set null? Yes. So this is what we guys here. So on delete cascade rule, what it was telling, once you delete parent, child also deleted. On delete set null, what it was telling, once you delete the parent, child is not deleted, but child is converting as a nulls. Converting as a nulls. So these are the two rules are coming to picture after making relationships in between table. So these are your complete all constraints we discussed, guys. Here the total how many constraints we said, the 5 constraints, then how these 5 constraints are working, so that we discuss here. Okay now, so now what we can say, not null, unique, not null, check, primary and foreign. Okay, right. Now next one is observe. Next one is observe. Guys, can you remember here one thing? Suppose whenever you want to apply your constraint on a particular column, then internally every constraint purpose, your system is created one key identity number. Yes or no? One key identity number is created, that already I said to you. Yes or no? Okay. For example, let me see. Test number. Yeah, test number 8. Careful observe. serial number integer, serial number integer. Now I was given unique constant and some name. I'm taking here varchar 2 of some size, okay, to create it. Now you can see in this example what I'm doing here. I created one new table. In this new table on serial number column, I was applied unique constant. I applied, okay, fine. After applying this unique constant, what we said, for this unique constant purpose, internally your system is created one unique key identity, that is called a constant key identity, was created by system. If you want to see, guys, here, let you see. Now I want to insert into test number 8, sending values of 1 comma a, yes, accepted. But whenever you want to inserting the duplicate data, okay, then immediately, yes, your error is occurred. But constant key identity, can you identify? Can you identify? This is called as a, who will create it? This is system is created. System created means what we can say, this is a predefined constant, simple I can say key name, otherwise key ID. So this is why we called a predefined, means this ID or key name is created by system. Now you can see yes, y, yes, yes, y, yes. Okay. So that means this is called as a predefined constant key ID or key name we called, which was created by system automatically for your constant whenever you apply like this. Whenever you apply like this. Okay, now, right. But now the question is, sir, why should the predefined constant key name I want to take? I want to take my user defined constant key name. Is it possible? Is it possible to create a user defined constant key name? Yes, it is possible. If it is possible, then how to create? Okay, so that is called as a, the question is how to create a user defined constant key name or ID. So predefined means automatically created by system. But if I want to create a user, how he was created means, yes, we can, but a small syntax is there, the syntax option. What is your syntax? First, you have to mention column name. That's okay. As usual, suitable data type. If it is required size, you can give size. Okay. After that, you have to use your constant, is a predefined statement. Okay. Then you have to give here, okay, user defined constant key name you have to design. Understand, a constant key name you can give. After that you have to apply your constant type. This is what constant type. So whenever a user defined constant key name, whenever you want to assign or create, then column name after data type size. Then what we did previously, instead of writing this much statement, directly we are writing like this. Directly we are applying. So when you apply directly like this, then what happened, guys, here? For this constant purpose, your system is created. But user creation means compulsory you should give your constant user defined constant name and later constant type. So let you see this example I am going to take. So this is you system defined, but same thing. Let you see test number 9, serial number integer. After what I want to use constant key, and after constant key, user defined key. User defined key I'm using now. For example, UQ underscore S number. So shortcut some name I was given. So XYZ ABC. Okay, whatever you can give it. Okay, no? So this is constant user defined constant key name. Later constant type. What is the type? Constant unique. After that, so name and varchar 2 of some size. So let us see what happened. What we missed here, guys. So right parenthesis missed. Okay, constant spelling wrong now. Right. So constant and user defined key name unique, and later your other column. So let you see table is created. After table creation, as usual, you want to insert into test number 9 sending values 1 comma a. Okay, perfect inserted. The second case, if I'm inserting insert test number 9, okay, now I'm sending values, then 1 comma b. If I'm inserting, what happened, you can see it was showing error. But in this error, guys, can you identify unique constant is violated, but what is my constant key name? UQ underscore serial number. Previously, what is the key name? sys underscore C005876. So this is what I said. It's a predefined. It's a predefined. So this is what we said. Okay, this is what we said, predefined. But here, can you see this is user defined? Okay, now, so this is what we called as here predefined constant key name or ID, and this is called as a user defined constant key name or ID. So now this is the way how to create your user defined constant. Now see here, user defined whatever the name I was given, UQ underscore serial number. See, I was given the same thing. So whatever I was given my constant key name at the time of table creation and applying your constant, so that will be firing here. Okay, so this is the mechanism how to create it. This is the mechanism how to create it. Okay, so constant key name, and which was user defined, so now all of you clear now how to create a user defined constant key name? Come on, guys. Okay, right. So this is unique constant, how we can go to use it. Okay, so because unique constant is not allowed to duplicate data, so that's why this error is came. Okay, now, right, guys. So this is user defined and predefined, automatically created by system. But if you want to create your own constant key names, you have to follow this. Okay, right, guys. So the next level of constants, okay, how we are working with constant in the next level. So those we will see on Monday session, guys. So Monday we will go for the next level of constants, how to use on my table structure. Okay, that we will check it on Monday session. Right, guys. Thank you. Yeah, Mayur, that was when you downloading the software at the time, that DLL file was missing. So that's why that error is came out. So you have to do only one thing, reinstallation again. Okay. Otherwise, first you can download again. You have to go and download completely, then again reinstallation. Because sometimes what happen, while you are downloading time, some DLL files will be missing for a particular software. So if any DLL file is missing now, so this type of problems are coming out. Okay. So that's why you just go to, again you have to download and reinstallation once. Okay. Right. So Kumar, don't hurry but here. I will show you how to view the constant name. Okay, na? How to find out constant name, that we will see on Monday session. Okay. So don't hurry, buddy. I will show you. Okay. Right. Right.